Alright, so we're going to introduce the idea of a confidence interval in this lesson. So this is something that we're going to dress up later on as proportions and later means and some other things, but the basic idea stays the same throughout. So regardless of what parameter we're trying to estimate in the population, we are going to collect a statistic from a sample. And the statistic that we're going to collect here is a thing called a point estimator. And the value of that statistic is what we call the point estimate. So what we know is in an unbiased estimate, the point estimator is going to be somewhere close to the parameter. Okay, so when we do this with proportions, which is what this unit is about, the population proportion is going to become P. The point estimate is going to be the proportion of the sample, which is going to be P hat. And like if this is like the number line, right, and the proportion has to be somewhere between 0 and 1 because it's, you can only have 100% of something. If the actual population proportion is here, we would expect that if I took a sample of size n, that the proportion of the sample is going to be somewhat relatively close to that value. Now, what we're going to do is we're going to create an interval around this. Okay, so we're going to create an interval around the point estimate. And it's going to be an equal length to the left and to the right. Okay, so this thing is going to be in the center, and you're going to go to the left and to the right, and you're going to create an interval. And what we're going to do is we're going to ascribe to that interval what we call a confidence level. Okay, so it's going to be a percentage somewhere between 0 and 1, right? We're going to get a confidence level. And this is how confident am I, right? That if I took all the possible p hats, so if I took all the p hats, how confident am I that the interval that I just made will contain the p, the actual parameter? So if I take all the possible statistics that can come from a sample of size n, what percentage of them do I know will contain the actual population parameter? Okay, so essentially this is asking, if I've made this confidence interval, how confident am I that that interval actually contains this parameter? Okay, now I can make this 100% confident. I just have to make the interval infinite in size. If I make the interval infinite in size, I guarantee you that it will contain the parameter. So as I decrease my confidence, the interval gets smaller and smaller and smaller. Okay? So that's what's going on here. This distance, the distance from the point estimate to the end of the interval, is what we call the margin of error. Okay? So as I decrease my confidence level, my margin of error will get smaller. Okay? Now, what we're going to see later on is we're going to get these things called critical values. Okay? And these are something that control, in part, my margin of error. Okay, they're usually controlled by the degree of confidence, determines my critical value, and gets me to this idea of I can use that to control my margin of error. If I make my degree of confidence smaller, it's going to change my critical value, it's going to make it smaller, and my margin of error is going to get smaller. The other thing that plays into this is the standard deviation. And what that standard deviation is it's the standard deviation of the population. Okay? So if I know the standard deviation of the population, sorry, that's not correct. The standard deviation of the sample. It's the standard deviation of the sample. If I know what's going on with the standard deviation of the sample, then I also have another aspect of this that I can control. Because see, standard deviation of the sample decreases as n goes up. So what's happening here is the critical value gets changed by the confidence level. Make confidence level smaller, critical value gets smaller. Make sample size larger, standard deviation of the sample statistic is going to get smaller. So let me give a quick drawing of what this looks like in the big picture. Okay, so in the big picture, my confidence interval is going to be centered at my point estimate. I'm using p hat because we're talking about proportions in this chapter. I go out by the margin of error, right? So the confidence interval is the point estimate plus or minus the margin of error, right? Is going to give me the two ends of the confidence interval. All right. This margin of error, though, is broken into two components, and they multiply together. There's a critical value, and there is the standard deviation. Okay, and they get multiplied together. So it's literally can be written as p hat plus or minus, well, the point estimate plus or minus the critical value times the standard deviation. Critical value is largely controlled by the confidence level. As the confidence level goes down, the critical value also goes down, okay, which makes a smaller interval. In standard deviation, as the sample size goes up, the standard deviation goes down, which would also make the interval smaller. So there are two major ways to make the confidence interval narrower. And we'd like to have nice, tight little confidence intervals. One is either not be so confident, or two, take a bigger sample. Okay, so we're going to look at this a little bit more detail for proportions over the next couple of days, but this is in a pretty straightforward way. So what is this interval again? Given the confidence level, right, the confidence level, I am that percent between 0 and 1 confident that the actual proportion or the actual parameter is going to lie on that interval. Another way of saying it is that I have a 1 minus the confident percent that the actual proportion is on the outside. So usually, for like all intents and purposes, we tend to use like 95% confidence intervals, which is that magic 0.05 error on the other end. All right, so there you go.